Hey, good evening, everyone. Welcome back to my channel, AI Wise. Before we start, I have a few things to share with all of you. First thing is, I have given you some links at the bottom, as you can see on the page. The first one is to make sure you subscribe to my channel. If you're watching on Twitch or YouTube, my channel link is given below. It's actually by my name, Setu Choksi. You can subscribe there. The second thing is we are going to do a lot of hands-on, and the hands-on setup is also given, which is your step number 2. Make sure again you have set up. You can use Gitpod, Visual Studio, or download the code to run it on your system. You can also use it locally, as long as you make sure the requirements file is satisfied. You should be good to go. There are a few reference papers that I've done in today's session, and they are also available on the link that I've given below. It's a Dropbox link, so you can download, do it. I've done a few annotations that we will go over today's session and get started. So I'll just wait for a few more minutes for people to join in. In the meanwhile, make sure, again, subscribe to the channel, set up your GitHub so that you are good to go. We are going to jump straight into the hands-on fairly quickly and download the papers if you are interested in. One more thing, just checking with everyone, is this is the part 2 of the session. The part 1 we had done it last time, where we had introduced what is multi-armed bandits. We had also looked at some of the basic algorithms as well. So in your comments, be it Facebook, Twitch, or YouTube, can you just write a note if you are attending for the first time, or would you want me to kind of do a quick revision so that I know how to kind of tackle it. So just while we wait for a few folks, just let me know in the comments if you want me to do a quick revision, or if you're coming here for the first time, then make sure you subscribe and then write the comment. So just stay put. In a couple of minutes we will get going. All right, let's get started. So these two sessions that we are doing are around multi-armed bandits, and we will look at the definitions of what multi-armed bandits are and how they play a role for the reinforcement learning. So this is our second lecture. Last time we covered a few of the fundamentals. Today we are going to look at our algorithms. We are just going to do some deep dives with those algorithms and do a comparison and understand how these algorithms like UCB are developed and what are some of the new concepts that are in there. And as we go along, we might jump for the next session, we might jump into more algorithms, or we could just keep building on the concepts or applications depending on what you guys are interested in. Now let's look at some of the algorithms that we have. So reinforcement learning, if you recollect, was the idea that instead of a typical machine learning which just takes an input and an output, over here the action that the agent will take, the agent is also the algorithm or policy as we call it. It's going to observe the state and define an action, and based on that action the world will give it a reward, and it will use that learning to build up its policies as it goes along. Now that's process going to keep continuing, and that's the idea of reinforcement learning. We had talked about last time again how we use training the dogs to kind of do a fetch or fetch a ball, and to train it we give it a candy. So if the dog goes and fetches the ball, we give it a reward, which could be candy or some sort of a treat to kind of make an association that, hey, what action that you just did is good as well. And that's a concept for us in terms of what is multi-armed bandits as well. Now when the rewards are not delayed, it's a bandit problem. Now when we looked at reinforcement learning, last time we looked at a lot of different types of algorithms. We discussed about the algorithms in chess or Go, where your rewards will happen after a lot of actions have taken place. So you won't know whether the action that you're taking right now or in the next two steps, is that going to make you win the game or going to give you better rewards. So over there your rewards are delayed, and there's no easy way for you to identify what steps you're taking right now is optimum. So in the multi-armed bandit, the idea of a bandit problem really comes up from the fact that if the rewards are not delayed, you're looking at a bandit problem. So that's where the word bandit really comes in from. Now again, we had a few observations. So before we kind of go into a lot of different aspects, some of the things that the key observation that we are going to follow today is the need to go and do exploration. So at some point in time, we will have to do or explore all the arms to then figure out which arm that you're going to do. And that's a policy that we are going to figure out is how do we do that arm picking where we are going to do the exploration. The next one that we have is exploitation. Now once we know which arm is giving us better rewards, now we want to make sure that we are able to exploit that best arm or that bet machine in the example that we discussed, to make sure that, hey, our long-term benefits are rewarded for that scenario. Now that's a dilemma that you will work with, right? So your exploration is giving you more knowledge about the arms. Your exploitation is helping you maximize the reward. And at some point you need to kind of do both to make sure that, hey, if the states have transitioned, you're not losing out on that information. But at the same time, you want to make sure that you are maximizing your rewards for your benefits as well. Now, as we go along, right, the key question comes is how do you solve that bandit problem? And the bandit problem for us is how do we do exploration versus exploitation? So there are two simplifications that we are going to do. The first one is we cannot work with long-term rewards, right? And we looked at a few examples last time around where we wanted to do lose weight. right? And a short-term reward in that scenario is going to be, how much time do I exercise? The other one could be, hey, I want to maximize my click stream. So I'm going to look at my session duration. Or I could have a video site on which I'm trying to kind of maximize that. So I would look at view duration. So these would be short-term rewards that you could look at, which would end up becoming proxy for a long-term reward that you are working towards. And coming up with this is essentially becoming your secret sauce into how you will design your multi-armed bandits problem. The second one assumption that we are going to make is whatever action that we are taking right now is not influenced by the previous action, right? So each step that we are going to kind of take is independent of whatever actions that have happened below. So let's say if you have three machines that you are playing with, let's say machine A, machine B, and machine C. We are just going to work with one of the machines, and we keep on doing that. So every time we pull an arm, let's say pick machine C, that's what we are going to continue with. So we are not going to get worried. We are not going to worry about the fact that, hey, we have kept on picking machine C over the last 20 iterations, and that's independent of that. So these two simplifications really help out in simplifying the problems that we have for multi-armed bandits. Now, the agent design that we are going to look at it is as follows. So at time step t, we will observe the states, and these states could be, how much rewards each arm have got, or in a case of a contextual bandit, we are going to look at, what context do we have at the moment. And then on that basis, we are going to pick an action or an arm, as we will call it. Either it could be exploitation, where we are picking up the best arm, or it could be exploration, where again it could be either policy based or a rules that we have defined, and your output of that agent is going to be that action. That action will act on the world, it will give you a reward, and you will go through that next time step and continue that process. So that's how that's how the agents have been designed. Now let's look at some of the basic agents that we have at the moment. Now last time we looked at Epsilon greedy, where we said that, all right, for us to get started, we will pick a value of Epsilon, with, let's say 0.1. The values have to be ranging between 0 and 1, which means that when we say 0.1, it's a 10% probability. So with a 10% probability, it's going to pick a different arm, and with a probability of 1 minus epsilon, which is going to be 90%, it's going to pick the arm with the highest expected reward, right? So that's how we kind of keep on doing exploration and exploitation. But over here, there is no guarantee that you will pick the best arm, right? So your arm, last time we did a few experiments as well, and we did notice that, your probability that you will pick the arm, we had picked a Gaussian arm of 0.9, and if you ended up picking that, there's no guarantee that you will you will end up picking that. You could end up on a suboptimum arm, and just because it has gotten more and more rewards, you would end up picking that all the time. So that's a logic that we have to play, suffer with. Now, as we get into it, there are a lot of new methods that we could work with. We would say that, hey, instead of deciding that epsilon first, I could play with all the arms equal number of times, and then based on my rewards, I would then start picking the best arm over and above that, right? So I would look at explore first, and then exploit, where then I would keep a small value of epsilon, where it would start playing with that. So that's another way to kind of look at it. The other two ideas, if you have done any sort of machine learning, this would be super familiar with you, where you are going to look at it in a decreasing fashion, where instead of starting with a very, very low epsilon value, you start off with a very high epsilon value, and you keep on decreasing as the time goes by, right? This is similar to your learning rates that you had seen for your deep learning or your neural networks, where as the time progresses, you will have some sort of a schedule of decreasing that. Either it could be step, it could be linear, you could do an exponential or a cosine formula. There are a lot of different ways in which you could look at it. So again, same ideas could come with that as well. And that would be called epsilon decreasing. The other one, some recent papers have talked about where adaptive decreasing. Again, similar ideas from deep learning. So instead of looking at a scheduled interval, you are working with how much your model has learned, and on that basis you will define your epsilon value, right? So rather than having fixed episodes where you're saying that at time t, I'm going to kind of decrease my epsilon by half, at time 20 again I'm going to decrease it by half, that all of that doesn't really need to happen. So you make a call based on what you have learned so far, and on that basis you may or may not decrease your values of epsilon. Now again, the concepts are very similar if you're familiar with Q-learning, again, which is an idea in reinforcement learning. It is the same thought process behind that. So I'll just take a pause to see if there are any questions, anything that you have written in the comments. All right, let's continue onwards with our concepts. So this was our naive algorithm that we had, something that we looked for epsilon as well. So now instead of saying that, hey, we are going to pick, define on an epsilon, we say that, hey, I'm going to give each arm equal number of trials, and then based on those trials, I'm going to pick the best arm. And again, there are a lot of different ideas that are around there where we could say that your first step is where you are looking at exploration. Your first step is where you are looking at exploration, where you are exploring all the arms. This could be done either one arm at a time, or this could be done in a round robin fashion, where you start with arm 1, 2, 3 and keep on doing arm 1, 2, 3 all the time, right? And your exploitation is where you have picked your best arm and then you continue exploiting that arm, right? And in a lot of these scenarios, this could be very, very valid, where instead of dividing and saying that, hey, I'm going to look at all the 3 arms, I just want to identify the best arm, and this could be your best ad, or this could be your best creative that you're trying to work out with, and that could be the best way of looking at it, right? And this is often in the world of reinforcement learning, often the idea around best arm identification, and something that people have looked at. So now again, you're going to kind of sample each arm. So over here, the idea is that you are going to explore and then commit. So you are going to wait for that exploration before that happens. And there are some assumptions that you make beyond that. So over here, what is the difference between the 2 arms, between the means of the 2 arms, and that's very important. So now you could do the same thing as we described before, is let it play for n number of times, and that n could be predefined, or there are some of these concepts where you could say that, my n for a single arm is going to be defined by this formula that you see on the right hand side, where delta is the difference between the 2 means, right? And if I have 2 arms, then this n will be multiplied by 2. If I had more than 2 arms, then let's say m, then I'm going to multiply this by m times, right? And then the delta becomes the difference between the max and the mean min of that particular value. Now, once we have done that m times, Then we kind of go into the exploitation mode, where again I'm going to pick the arm with the highest expected reward. Now again, the other assumption is what happens if we don't know the means between the two arms. So I would say that there are again some of these concepts where we could work with, where we could come out and say that, oh, I don't know the means between the two, so something that I can dynamically calculate, and then I will look at whether I'm meeting a certain threshold. And again, a lot of these thresholds are purely driven towards the fact that I want to kind of empirically quickly find out which arms are going to be optimum and come to those values as well. So these are some of these explore then commit problems that we work with, and let's look at this in a little bit more details, and there are some more examples, so we'll come to that in a moment. So let's switch over to our code itself and see what all we have at the moment. So I hope that all of you have set up the code as well. If you have not, then I would say go out and set it up. If you go to my GitHub, which is GitHub C2C, I'll paste it in the comments as well. If you have, then we could get started. So I'll just give a minute for people to just make sure that we have it set up before we get going with that. All right, let's get started. So I already have my environment set up, and then I have two explore then commit policy, where the first one is where I know the gap, right? And over here I've assumed my gap to be just 0.1. So for my examples, we can pass this as a parameter and say, hey, what is that gap that we are looking at? And then I have a random stop where it's going to determine what is the largest mean between the two, and then we can play around with these values, right? So let me just import these values and get going, and zoom in a bit. All right, so I have imported these two policies that I've defined. Now let's pick our first policy itself, where we don't know the number of which is the mean between the two arms. So I'm going to pick etc random stop, and then I will tell it my number of arms, which are 3. All right, and I have picked Bernoulli arms, and my rest of the configuration remains the same. And I just did a very simple chart where I'm going to plot the rewards and cumulative rewards over time period. So my time period is set as 10,000. So this is 10,000 times that I'm going to pick between the 3 arms that is defined by the policy random stop. And knowing from the arms itself, I know my arm 3 should be the best arm because I have kind of predefined it. But in real life, that's not going to be the case. All right, so I have my code defined. Now let's run through this. Let me kill the terminal and start again. Let me refresh my code spaces. Okay, sometimes this happens, especially when you're live. Let me kill it and start all over again. Give it a minute for it to get going. In the meanwhile, if you have any comments, anything that you want to know, just write it in the chat. I will spend a minute to respond. It's almost set up. There we go. Hopefully I still have my, yep, I still have my setups. All right. Let me run the code and zoom in a bit. Maybe the Bernoulli arms a little bit too much. Let's just kill the terminal again and start with Gaussian arms. Also needs the horizon. I think that's what is missing in here. Maybe let me move it inside here and run the code. I think there is some issue with this. All right, so over here you can see that very quickly it came on to the second arm, which was much more useful for us, right? So now it played the arm. Let's go back to the code in here, and I'm looking at the largest mean, and then till it comes up to a certain value, which is defined by basically time t over t, and some alpha value that we are kind of taking up. Right. So, and you will see this concept come in later on as we get on to more concepts around UCB and others, that somehow we'll kind of use this variance again to kind of work that out. Right. So as long as my difference is still greater, my random is going to be false, which means that I am going to go into my exploitation mode. Right. Till then, I'll keep on preferring my epsilon value to be 1, which means that I'm going to keep on exploring all the arms that I have at the moment, right? But this is not a very intelligent way of working through that, right? So if we let's say we go back to our previous example where we were looking at epsilon greedy. Now let's just play around for a while with different epsilon greedies, right? So everything remains the same, and let's just work out the logic again. All right, so over here my arm 0 got picked up early on, and my arm 2, which is more optimal, didn't get picked up that many times, right? So even though I know I have set up the arm, it's picking one of the worst arms that I have, which is not even giving you enough rewards. So a lot of times, it depends on, how you are initializing it. When I run it again, then it picked the best arm. Because of that randomness of how epsilon greedy works, there is nothing to control it, right? So it will keep on, settling down on suboptimal, which is something that I shouldn't be looking at. So that's where epsilon greedy is not going to be do it, and some version of explore then commit options come into play, right? Where I could pick an arm based on what I'm picking, based on the criteria that I've set, where initially I'll do my exploration, then I will jump on to my exploitation. So that's a concept that we have so far. And recently there was a paper in NIPS, which was in 2016. You can see that, hey, it was kind of looking at a lot of different concepts of what happens when you have known gap. So again, two different ideas that were there, and then again for the unknown gap, where alpha in the current code that we had, we picked the alpha value of 4. The authors suggested a value of 8. Now again, these are ideas that you could use it, which become much smarter. So it's not like, hey, these ideas have been kind of explored. Something to think about as we go along. The next one that we could look at it is empirical means. So you could say that, hey, we are doing this exploration in the first step. Why don't we just calculate the means of the arms? And then, after a certain point, let's work with the best means that I have. Or alternatively, I could keep on calculating the means at every time interval t, and then pick the arm that has the best means as well, right? So my means are just going to be the rewards until time t, and you just take an average of how many times that arm was pulled, and you get those values. So now let's jump back to our code again and see what values, how do we kind of calculate those. So let me jump back to my code. I have an empirical means, which is again a very simple one. So for each of the index, I'm just doing rewards by how many pulls that we have, and that will help me pick the best arm. So now let me set this up as well. So from policies, all right, and then let me set up my policy where I need so my number of arms are 3, and again let's keep the Gaussian arms, so we don't have to kind of redo the whole process. Now let me change this to empirical means rewards, and let's just run the code. All right, so very quickly it came on to the arm 2. Again, based on the first reward that we have, my mean very quickly decided that, hey, arm 2 was there, right? So this is the as optimal solution that you can ever get, right? Where each arm was played at least once it determined that, hey, arm 2 was giving better rewards, it worked that out, right? Let's try it again. Right, again the same thing, right? So as and when it kind of goes through the means process, it can work through a different logic as well. So let's play around with some more ideas around these, and let me give you paste a problem in the chat where you can play around with different types of arms. So we are going to create 9 arms with each one of them as Bernoulli experiment, where 0.1, 0.2, 0.3 all the way up to 0.9, and this is one of the very easy experiments that we could end up doing. So let's set that up. All right, so I'm going to pick a Bernoulli arm, and I need a few of those. This is going to be 0.2, 0.3, 0.4, 7, 8. Right, so now I have 9 arms. So the polisher should know that it has 9 arms, and let's try. All right, so over here, it did play around with a few of the arms before it decided that it's going to go with the arm number 8, right? and that's what we have at the moment, right? Let's play around it one more time. Again, my arm gets picked up. Again, depends on the means that we have. So empirical means becomes a very easy way of working through that. So initial phase is just going to do exploration, where at least it's going to play one arm till it gets enough values, and then it will start to exploit all the arms that we have at the moment. Right, so that's how empirical means work. But again, there is no exploration after that first step. So there are some improvements that people have suggested and they have made, where now the idea comes in from upper confidence bounds, right? So we are going to blend exploration and exploitation, right? So over here we are going to pick the arm with the highest A at any given point in time. So my first term, which is there, it's essentially my exploitation, right? So I'm taking my average rewards at any point in time, and then I add a term which will define whether I should be doing exploitation or exploration, right? So term T is the time period, time T. NT is telling how many times a particular arm was picked, right? So now if this arm was not picked too many times, then the right hand side term, which is marked at exploration, is going to become larger and larger, and once it has enough rewards and it has calculated that enough number of times, then you will see that your left hand side term, which is your average rewards, dominate the equation. So these two essentially kind of balance out your exploration and exploitation, and that's a very nice way of playing around with that. So again, let's jump back to the code and see what values or what explorations that we get out of that. I'm jumping back to my code. Last time we played around with UCB. Let me just remove this. And we had picked UCB with 3 arms. Oops. So now let's make it 9 arms and see how many times each arm gets played. Alright, so again you see that my arm 8 gets picked up, which is the Bernoulli with the probability of 0.9, and that's how we kind of work that through. But you see that instead of these rest of the arms being very low, there is some amount of exploitation, some amount of exploration that keeps on happening, right? So it doesn't completely lose out, and let's say your rewards are changing over a period of time. You do balance out the fact that, hey, you are exploring other arms as well and not completely focusing on your best arm all the time. So this is another approach that we can explore rather than work that through in. So there's one question on the code itself. Let me just answer that. So the question is, when ARM configuration is Gaussian, there was only one parameter. Usually Gaussians has 2 parameters, mean and variance. Are we assuming the standard normal random variables here? So what I've done in my arms is, you're right, Gaussian does have 2 arms where you're looking at mean and variance. Over here, my variance I've already defined, right? So I've defined the values as 0.05. So I don't have to kind of worry about that, right? But in case where I want to set up an arm, a Gaussian arm with sigma, I can do that as well. So I can say Gaussian arm with mean of this thing and sigma of whatever value that I'm interested in. So that's one way of defining that, for our sake of discussion, where we are just playing around with different algorithms. That's another way of looking at it. I hope that answered your question. Now let's do a UCB with 3 arms. We played around with that. Let's see, do we get different answers if we play around with those different values. So there's going to be slight variations in each one, but for most part you will see that your values are thresholded about that, right? Now there's like a lot of literature around that is, how do you kind of balance the two equations out here as well. So let's go back to the presentation. And look at the different varieties that I have at the moment. So people have done, have taken the right hand side of the equation and come up with a lot of different varieties. And a lot of these is, how do you minimize the regret? How do you very quickly come to the optimum arm as quickly as possible? So, again, I've done some of these policies in there. I'll give you some time to play around with. In 2002, there was this tuned model, which again kind of takes a similar concept, but instead of the value 2 that we had before, right? So we did 2 log t times n. So this 2 is kind of taken up, replaced by another value. It could be alpha. And you could have UCB alpha. You could also have another value over here where I'm looking at VK. VK essentially is the square of the rewards, right? So you take the square of the rewards, mean rewards, and you subtract it by the square of the means, right? So you come up with an intelligent value. This was further expanded by Audibert in 2009. Where they added another term, so they expanded on it before, and the more recent one said that okay, you can set up a very quick threshold by picking either 0 or another equation that they have. So all of these were kind of driving towards the policy is what is the bottom theoretical limit that you could come up with. Now, both in practice, when you work with UCB tuned or UCB-V, which stands for variance, it becomes very convoluted to kind of manage that in practice, right? Especially if you have multiple choices, it makes it very, very cumbersome to work with those choices when you're kind of having this VK term, which is essentially the square of the reward. So again, you're driving up a lot of computations in there. So typically, working with a variation of UCB or UCB alpha could be a very, very good starting point. And that's my next experiment for you, right? So I'll give you a couple of examples to play with. And you tell me, hey, between my empirical means, my UCB and UCB alpha, where instead of the value 2, I can play around with any alpha values that I'm interested in. So let's try out and see, does it matter, which values do I pick, or is UCB or these variations of UCB really add any value to the process itself? All right. So all of you know what the Bernoulli distribution is. So when n is 0, the probability is 1 minus p and then p for 1, right? So if the probability is below that value, it's going to give a reward 1. If it's 1 minus p, then the reward is going to be the value 0, right? So that's how we would think about it. So I'm giving you a few examples to play around with, where you can use the easy experiment where you know what your groups are. There is a slightly difficult experiment with here, and I will highlight what those differences are. If you see these arms, right, the rewards are nearly the same. Your bottom ones, again, I've kind of grouped it below, and then you have these remaining arms which are just sitting in middle, quite separated, right? So where there's decent amount of separation between them. So let's play around with that and see, does empirical means or UCB or UCB alpha give me a much more give me a better choices or less regret as compared to any one of them. So let's start with the first one, and I will play with all of these three algos, and then we will move on to the next one. Again, for all of these experiments, we will pick Bernoulli experiment, Bernoulli arms, instead of Gaussian arms, so that the rewards are kind of nice and clean, and we don't confuse the algos with the overlaps as well. But again, something that we can play with it as well. All right, so let me go back to the code. I have my 9 arms that I have defined. Okay, my UCB is defined and my counters are given as below, right? So my arm 8 was picked about 8,500 times. Now let's pick UCB alpha. So I've given the value of alpha as 4. Feel free to pass any alpha that you want. And for our experiment's sake, we will pick the alpha value as 0.5. So I'm going to pick another policy. Right, it's not imported, so let's import that. I have UCB alpha, import UCB alpha. Right, so I've imported this value, and then I'm going to pick the arms, tell it that it has 9 arms, and then my alpha value, I'll set it to 0.5. So this is same UCB, but instead of the value 2, I'm picking up 0.5. Right, let's play with this. All right, you saw that as my alpha value goes to a lower value, it starts to represent empirical means, right? So now my arm 8 has been picked way more times than that. So I know that my total regret or total times that I've picked an optimal arm is better, right? Let's try with another value of, if I put a value of 2, this becomes UCB. If I pick a value of 4, let's see what do we get. Right, as you kind of start increasing the alpha, it's a balance of how much exploration that you want to do. Right, let's go back to 2 and run it and see. All right, so again, these numbers are slightly varying, so you will see changes every time you kind of run through this. But that's your pieces. Now let's do our empirical means and see what do we get. All right, so let me just remove these policies and let's run empirical means. All right, so empirical means, you see that it very, very quickly comes to the number 8 arm, which is my Bernoulli with P of 9. Right, so that's how we kind of work through this logic. So in most of these scenarios, you did find that empirical means was kind of way better than UCB itself. Now let's try the harder problem. Right, so we had let me just paste it here so we can play around and update these values. So my first arm was 0.1, 0.02. And then as I came along, I had 0.95, and then this was 0.805. So I've made the arms slightly more difficult, right? So again, it should be picking one of these 3 and not any of the other arms. So let's try empirical means and see what do we get. So you can see, right, your 8 and 7 were being picked up much more often. Again, 8 actually did a better job. So now 8 is your last arm that we have. Now let's try our UCB, and then we will pick our UCB with 0.5. So let's see how the UCB does. UCB was all over the place, right? You saw that it couldn't distinguish between the last three arms very well, and it was struggling to figure out which one is better. And in real life, this may or may not matter because these are very very minor differences between the two. So your arms 8, 6, 7, 6, and 8 were working out much differently than what you expect. How about when we do UCB with small alpha, which is like a balance between your empirical means and your UCB itself? Right? Similar thing that you're seeing, right? Your arm 6, 7, and 8 are being picked um, much more. Again, it's not able to very quickly identify which arm is really better. So that's where you are seeing the difference, where it's doing exploration as well, just to see if those arms are producing a better output, because in reality you won't know the difference between the two. So your arm 7, 8, 6, 7, and 8 are being picked up again. All right, so I have done a few more. So I have the UCB-V as well. Now there is nothing required in your UCB-V. Just import those values, import those functions, and get started. And then I also have UCB Plus as well, right? Where again it's a slight variations of what you looked at before. So I'll give you guys a few minutes to play around with and see what values you get. Let me know in the comments. In the meanwhile, I'll see if there are any questions on the chat as well. All right, do I have the audio? Okay. Sorry, I probably was speaking on mute. Okay, so let me go back a bit. So the question was from the user on Twitch, Silings123. Is there any difference in the UCB algos? Let's say you compare Epsilon greedy to any other form of multi-armed bandit like UCB, UCB plus, to others. Is any UCB superior to others, right? So a lot of these logic that you have seen, right? So what if you go out and read the paper, right? So they are kind of minimize. A lot of these concepts are coming towards the fact that let's try to minimize the regret, right? And what is the lowest theoretical bound that you can come up with? So a lot of these authors have come up with different logic of how to kind of balance exploration itself. There's another paper which I have included in my set. I'll probably come back to that before and work that through. So what we can possibly end up doing is the fact that, hey, this particular set is just trying to kind of minimize that exploration and so that you come to that optimum arm very, very quickly. So that's something that the authors have tried, but from a practical perspective, right? As I mentioned before, that when you have this VK term, now this VK is looking at squared of the errors, right? And in the UCB tuned, the logic is even more complex, where you do a squared of the error, subtract the square of the means, and then you calculate another arm, and then you substitute back. So it's a complex step, right? And then from a practical perspective, if you have a lot of options or a lot of arms, your UCB variance models might not be very, very productive, right? And there's another paper which I'll mention towards the end of the session. They call UCB Boost. And their whole idea is that, hey, when you're working with recommendation systems or when you're working with ranking systems, you are able to decide on that arm fairly quickly. And again, they came up with their own logic in there. I've not included the code, but I can certainly refer if you guys are interested. So there is no difference, bottom line, right? All of these are theoretical guarantees in where you can minimize the regret. Sometimes keeping it simple might be there, but it comes at a cost of how you want to kind of balance exploration versus exploitation itself. And that's why we were doing that experiment before. So the part where I think I missed the audio was where I was doing these difficult arms itself, right? So there are a lot of these arms which is essentially the hard problem, and then Bernoulli is 0.1 where it should come out fairly quickly, right? So people do try out to play around with some of these logics much easier, and the reference papers that I gave you earlier in the session are essentially kind of geared towards the similar concept as well. So I'll just take a pause. I do see some of these questions in Twitch and YouTube. So I'll just take a moment to answer some of them. Okay. All right. So, yep. So no problems with the questions. These questions are good. Sometimes, when people ask me questions, it kind of helps me think through, hey, why didn't I think of that before? So certainly would be interesting to play with. So a lot of these papers that I kind of talked about comes in from a lot of theoretical guarantees around, how can you kind of give guarantees towards minimum regret. And I'll kind of share with you the papers again towards the end. But while we are doing that, let me share the screen again so you guys have reference to the papers as well. So the first one, so if you are on Twitch, I would prefer you be on YouTube, but it's completely okay. I do these sessions on a regular basis, though not on Multi-Armed Bandits, but different areas on AI and cloud. The code is given here, bit.ly, GitHub, MAB. The capitalization is important, and work through that. And the papers are given here, right? MAB YT-29. So this will give you the papers that I have referred in today's session. And again, feel free to ask me the questions later on as well. So there's a question. Thanks, Ceilings, to answer that question. All of these are recorded and are available on YouTube. So let me ping the link for people who are on Twitch, where you can find this video almost immediately after that. And again, leave me a comment, right? So sometimes I don't know whether I spoke too fast or I had, some concepts didn't make sense. Leave a comment, and even if I get like 2 people, 3 people, we can get on a stream and answer some of these questions, because I love these sort of interactions that are there. So Twitch or YouTube doesn't really matter. Pick your platform. I'm even streaming on Facebook, but I would prefer Twitch or YouTube. Either one should be okay. So anyways, the paper links are there. I'll just pause for a moment and paste the links in for everyone to go with. All right, give me a moment. Yeah, I think it has certainly exploded, but not a lot of people, talk about multi-armed bandits, which is very surprising. One, conceptually they are very, very easy to understand, easy to digest, and something that you can explain to business very, very quickly. Some of the slides that I shared with all of you are something that I've used internally to convince my management. Of course, I've skipped some of the internal topics, but the ideas were the same, the concepts were the same. So we find it super useful. It works extremely well in practice. That much I can tell you for sure. All right. So I think we are almost towards the end. I do have other topics. I don't know whether you want to do it this time around. So the next section that I thought we will start off with is on Thompson sampling. I don't have the code for it yet, but something that I will add next time. So what do you guys think? Do you want to refer, do more of the algos, or do you want to take a break and then I can see you guys next week, where again we can go over the same logic or others in there? No, I don't have a paper in Multi-Armed Bandit. Would like to refer you in my thesis. Just refer my YouTube channel if it's okay, or it's completely fine. I'm here so that you guys learn and share my knowledge. So yeah, I'm happy that it's helping you out. Yeah, I do. I've not done complexity analysis, because a lot of these are theoretical guarantees. Of course, read up the papers, post a comment either on YouTube. I don't know if you can message on Twitch, but if you can, then, send me a message. Would be happy to answer. I'll make it very clear I'm not very good at explaining the theorems, and that I've not done derivations on it. I do spend time to understand, what the author is trying to say, and what their logics are. Try to implement that in code, and prove it with with different logics and see whether it makes sense or not. Because the only way you can learn and get good at it is by coding and playing around, and that's how you become better at a particular logic. So I think let's pause for today. I will be online again next week, same time. It's 7 p.m. Singapore time. So again, if you have any comments, anything, we could work through that. And yeah, so I think there's one more question. Is there a chance where you can explain an example where the rewards on a Gaussian arm are not truncated? I'm not sure I understand your question. So you could artificially, I have another arm that we have used internally. No, I think I've not put it in my code. There's another one where you could do discrete arm, right? Where let's say where your rewards were discrete over a period of time, depending on the offers that you have done, you could randomly pick a value from that, right? And there's an algorithm that we can explore later on, or probably the next stream. It's called BESA, BESA. And that kind of does this multi-round competition between arms to then pick which arm it does. Again, it's fairly involved in there, but something that we could play around with it as well. So depending on what you guys want to do, we can kind of take it up. So this PPT is not available anywhere. Again, I'm happy to post it, but all of these are on videos, so feel free to play around with it. One of the other things that I'm going to do is remove that interaction piece and just do the video. So all of this you can copy it or use it, but then again, happy to post the PDF if you guys are interested in it as well. All right, so the question again is, let's say what happens if my rewards are not between 0 and 1 and the variance is 20. All right, so let's play around with that. I think that question had come in. I don't know if you asked me that question before, but that question was certainly there. Let's do that, right? So let's pick maybe 3 arms, and let's do a Gaussian of those arms. So let's pick an arm with 50 and sigma of 20. All right, and then let's pick another arm with 30 and sigma of 20 again. Do you have any other suggestion? Let's do 10 and then give a bigger sigma value. Let's say 30, right? So this becomes a slightly more difficult problem to play with. All right, so let me go with some of these things, right? So one of the things that we had given was that, hey, what is my lower value and amplitude? So something that we are setting up as well. All right, so you certainly give a lower value in here. So the arms know what to play with. So I think this might not work out. Okay, so let's pick 70 and a distribution of 30. So in this case, my lower value could be 10 and my amplitude, hold on, My amplitude is certainly not going to be 1, so I just need to give my lower and upper values. So what happens in, when I do a get reward for all my base policies, right? I have to, basically I have a code which kind of, does the normalization itself. And I could set this up, right? So when I set my policy, I need to set up my lower and amplitude as well. So let's pick, when I set up my policy, empirical means, let me give it a lower value of, let's say 1, let's not do 0, and amplitude of 100. I think that should be sufficient enough, right? So it's going to scale, or 150. So it should be sufficient enough to scale between those values. So over here, my arms that should be picked is again number 3. And let's see what do we get with empirical means. Index out of range. All right, sorry, this is 3 arms. All right, so over here, my arm 0 got picked up because my mean is higher. My Gaussian third arm has a higher spread, right? So it's much flatter. Let's try that with different policies. All right, so let's try UCB. I'm going to pick the same. Sorry, making the same error. All right, so your UCB actually didn't do a good job at all, right? It was continuously exploring all the time. So of course it depends on your distribution itself. All right, so now let's try our UCB alpha with 3 arms, and let's set up the amplitude in here. Right, so this essentially, when you set up these factors, right, rower and amplitude, this basically again scales it back between 0 and 1, right? So that's how we structure it. So UCB in these sort of arms is actually not doing a good job, right? It's still doing exploration where it shouldn't, right? So let's tighten our bounds a bit. Of course, some of these might go beyond those values. Again, you get the similar values as well. So what's happening in this scenario is, it's kind of continuously exploring, because again, this in my scenario would be a difficult problem to play around with. It's at no point in time, it's decided on a particular arm itself, while your empirical means did get to those values very quickly. So of course you can play with these arms as you go along. But just make sure that you are setting the lower and amplitude itself, so that will help you scale the reward before it goes into the policy. So I hope that explained to you, how some of these things work, and I hope it was useful. There's a question again on YouTube. Hey Vidyaraman, it would be great if we can have application done for RL, maybe A/B testing or a promotion planning or robotics. I hear it's used there as well. Yeah, sure. Let's pick. Next time let's do a real example as well. Again, a lot of these data sets are not easily available. But what I can do is create a synthetic data set. So we can play around with that. We could do it as promotions. We could decide on some of the users and play around with that as well. There's another one that's there on contextual bandits that we could also do. So we could do it for news articles. We could do it for video promotions as well. So those are some of the things that we could play around with and then decide of how to kind of implement this. But to kind of give you an example, right? Your ARM configuration is something in your real life is your choices that you will get, right? So when you are playing with your real life logic or you're implementing it, your get reward is a reward that you will get from your users. So let's say, did the user click or not, you will give it 1 or 0, right? So depending on what choices you have, you might end up picking this from the user itself. And at some point you might even have to wait for it to figure it out. So these are some of the things that we could play around with. This is a super deep topic. There are tons of algorithms that are there. We could spend another year. Most of you can write your PhD thesis with some of these things. But I would like to keep it focused where I know what some of these things that have worked in practice, something that we have played around with it quite a bit. So let's focus on some of the key algos that I know that work for sure, and then build upon it. And as we go along, I'll give you references of, hey, what you guys can go out and refer, which papers you need to read. And again, let me know in the comments once you get a chance to read the paper. I've just highlighted the key formulas that you need to know that you can directly implement, or that I have directly implemented in the code itself. So you can directly get on to what is important. Again, something that I've done. If you guys are interested in, I can certainly share with you guys my annotation, my notes in there. But again, I don't know what the interest levels are, so we could decide how we want to kind of structure from there. Is that cool? So there is one person on Twitch who says code implementation is probably the most interesting for me. So what do you like? Okay, so let me ask my folks on YouTube, right? Do you want to kind of spend some more time on the algorithms and the papers? Should I annotate more papers and share the code with you? So let's do half and half. No, so next week we have a guest speaker who's going to talk about augmented reality and virtual reality. He's my colleague on the Microsoft MVP section. So let's do code next week, where let's just spend some time on the algorithms itself. I'll pick out some of the good ones and then show you very quickly which ones are there. I'll give you some homework as well, so you guys can refer to some of the more algorithms, and then maybe we could have a kind of a discussion in there. So that would help get started as well. All right, then code it is. I'll pick out some more UCB, more distance-based algorithm. We will do a little bit more on the boosting, some of the more recent algorithms that have come into play and that work it out. So theoretical, okay, so there's one user who says, okay, let's do some theoretical as well, and why it's not used in practice. Okay, so let me do this. Next week, the UCB algos that we have, let me just show you some of the code and the complexity that is involved in actually the practical code itself. So let me pull that out, and then let's do a comparison in the paper itself and then apply it and see where it goes. So I'll pick up some few more algos and a few more papers to play with and share it with you, and maybe over next couple of weeks let's just spend some deep dive around some of these papers as well. So yeah, let's keep it to that.